Okay, this is day 2 of solving systems with augmented matrices. I just want to review one more time. You have 3 row operations that you're allowed to do. You can flip any 2 rows, you can multiply any row by any non-zero number, and you can add 2 rows together. Or you can combine some of these together. So you could like multiply a row by a number and then add it to another row. Okay, so let's look at this example here. First step is to take our system of equations and write it as an augmented matrix. And again, you put your x coefficients in your first column, your y coefficients in your second column, and then your third column is going to go your constant terms. And remember, what we're trying to do is we're going to use row operations to turn that matrix into this matrix. Okay, so let's take a look. I want to make this element here to be a 1. I'm not seeing a really easy way to get that to be a 1 without avoiding fractions. In the last example, I said avoid fractions if you can. But here, it doesn't look like we're going to be able to avoid fractions. So what I could do, if I want that element here to be a 1, I could take 1/3 times row 1 and then just replace row 1. So that means row 2 is staying the same. So let's just copy down row 2. Now, I'm going to take 1/3 times all the elements in row 1. So 1/3 times 3 is 1. 1/3 times -4 is -4/3. Just leave it as a fraction. 1/3 times 1 is 1/3. Now, I got a 1 here. So now I want to try to get a 0 on this spot. So let's use that 1 that we have. So let's multiply row 1 times -5. So let's take -5 times row 1 and then add that to row 2 and replace row 2. So we're going to take -5 times row 1, add it to row 2, replace row 2. So again, this time we're replacing row 2, so row 1 is going to stay the same. So 1 -4/3 and 1/3. Now I want to multiply everything in row 1 times -5. I'm just going to write it under row 2. I'm going to add these together. So I'm taking this row times -5. So -5 times 1, -5. -5 times -4/3 would be +20/3. And then -5 times 1/3 would be -5/3. So now, I'm going to take this row here and add it to this row. I'm going to add these 2 rows together. So 5 plus -5 is 0. 2 plus 20/3. Well, let's change 2 to 6/3. So 6/3 plus 20/3 would be 26/3. All right, now we got to figure out what is 19 times 3. 19 times 3 is 57. So I can write 19 as 57/3. And then 57 minus 5 is 52. So we get 52/3. Okay? All right, so number 1, we got a 0. Now let's try to get this element to be a 1. Easiest way to get that element to be a 1 without changing the 0 that you already have is to just multiply row 2 times the reciprocal of this element here. So let's multiply 3 over 26 times row 2 and then replace row 2. So row 1, again, is the same. Didn't change it. Now row 2, I'm multiplying that whole row by 3 over 26. So I'm going to get 0, 1, and then 26 goes into 52 how many times? Twice. So 3 over 26 times 52 thirds will be 2. Okay, one last step now. Now we need to change the negative 4 thirds into 0. You can see why I try to avoid fractions. I just wanted to do this one with fractions so you can see you don't have to always avoid fractions. It's possible to do with fractions. So let's multiply row 2 times 4 thirds. So let's take 4 thirds times row 2 plus row 1, replace row 1. So we're replacing row 1. So row 2 is going to stay the same. We got 0, 1, 2. And now I'm taking 4 thirds. And I'm going to multiply it by row 2. So 0 times 4 thirds is 0. 4 thirds times 1 is 4 thirds. And then 4 thirds times 2 is 8 thirds. So again, we are going to take this row here, which is row 1, and then this new row here that I got by taking 4 thirds times row 2, I'm going to add those together. And that's going to give me my answer. So 1 plus 0 is 1. Negative 4 thirds plus 4 thirds, 0. 1 third plus 8 thirds is 9 thirds. 9 thirds is just 3. So the solution to this system is the point 3, 2. Again, I'm just going to pull it up so you can see the whole thing. There it is. And again, when you're doing this on the assignment, I would like for you to write in these steps here. It's good practice. Write these steps in. Okay? All right, so let's say you're working some of these out and something like this happens. Let's say you get one of the rows to be all zeros. If that happens, you can stop. What that means is one of those special cases. That means it's infinite many solutions. Let's say this happens. You get 0, 0, and then a number. Well, anytime you don't have coefficients over here, that's one of those special cases. This would be no solution. So be aware of that. You can get no solution in infinite many solutions using row operations and augmented matrices. This is what it would look like.